So I've talked about the substrate there, I've talked about the TG, and I talked a bit about the CTE. The CTE in the X and Y axis, of course, is fine because we constrain that with a reinforcement. In the Z axis, there's a bit of a problem because we go between 50 and 260 degrees centigrade, a standard material will expand by about 4.2%. That's the typical number for a low TG material. I've put the word unfilled on there. I mentioned before we can use resins or we can use mixtures of resins or different materials in there. The standard was to use what's called unfilled, just basic epoxy resin. But we can put things in there that have a lower CTE. So we can mix in ceramics and we can actually make this expand at a lower rate. So we can take a material and actually put some filler in instead. Actually, there should be a third one in there. Okay, it doesn't matter. So we can take the TG to 175, and if we put a filler in there that expands at a lower rate than the resin, we can get down to around 2.8% between 50 and 260 degrees centigrade. And to put a value on this as well, if you're going to use lead-free soldering, you're looking at a value less than 3%, between 50 and 260. Less than 3% is going to survive around 6 times 260 degrees centigrade lead-free soldering. And if you look at the pictures underneath, you can see the problem is you have a copper barrel. The copper is actually constraining the material. The laminate itself is expanding at quite a high rate. So you can get cracks. This is actually a crack on the corner of a hole, so the pad's lifted up and actually fractured at the side there. You can get fractures in the copper itself in the middle. You see a small crack in the center there. Or if things go really bad, we end up like this and the whole thing just falls apart and delaminates. So the CT is a crucial property. It's especially difficult when you come to thick materials because the absolute magnitude is much higher. Thin materials, no problem, but thick materials are a huge issue. So we've come towards this kind of phenolic curing system for the thermal endurance. We've also come towards using a filler to get this CT value down as well. So people would talk about filled phenolic epoxy resins. That's what we're talking about here. So filled with a filler of some kind, and then using a phenolic curing system just to get that extra reliability for the lead-free soldering.